Hi everyone. Our team consists of 3 members. My name is Tong Wu and also Zhizheng and Minzhou. And our project's title is Yelp Reviews Explorations and Visualizations. So here is our the outline for our project presentations. We will first talk about the technologies we used and then give an overview of the data set. We will also talk about the challenges we faced when dealing with data, and we talk about first the data exploration phase, and then we will talk about the review stats prediction algorithms. We will also give a demo of web applications, and finally we will give the conclusion and the next steps to expand our current project. Okay, let me talk about the technologies we used. The main languages used in this project is Python, R, and JavaScript, and the Apache Spark is chosen to be the main platform. The libraries we used for machine learning are NLTK, scikit-learn, Keras, and TensorFlow, and we also use Seaborn and D3 for the visualization.
In this project, we use the Yelp challenge dataset, which includes 5 JSON files, user information, business information, tips, reviews, and check-in details. The total size of the dataset is 2.8 gigabytes. And this is a picture of the typical data structure in JSON file. While processing the data, we meet with following challenges. First, the datasets are not very organized. For example, some fields are empty, and some fields are not easy to normalize. And the datasets categories are not well balanced as well. Here are the analysis and modeling approaches we use, including natural language processing, sentiment analysis, visual analysis, and feature importance. And we find that sentiments are more obvious in the tips text as opposed to the reviews text. And the average user's ratings are between 3.5 to 4.5 stars. The average business ratings are also between 3.5 to 4.5 stars. We also generated a bigram word cloud for different star reviews. They can give us insights for customers' performance. This is the word cloud for 1-star reviews. We can see that there are words like won't back, poor quality, wasn't worth, long wait. However, this is the word cloud for 5-star reviews. There are more words like staff-friendly, good, great food, highly recommend, etc.
Next, we will try to use machine learning algorithm to predict Yelp review stats. We will first transfer the reviews into feature vectors, use bigram and trigram models. We also combine the result of sentiment analysis into the stats predictions. In order to balance the unbalanced data, we use the resampling technologies, and we also overplay the negativity of Yelp reviews, since the classifier often confuse 1, 2, 3 stars reviews with the 4 stars. And the best model we achieved is the random forest, which has 100 numbers of trees. The features we used are the numbers of review votes, the number of compliments, the reviews length, the numbers of positive words, the number of negative words, and the users' votes in the history, and the users' friends' average stars, and the users' fans' numbers. We also show the precision, recall, F1 score, and support for different stars, and we also provide the confusion matrix. Since the neural network are so hot these days, we consider to give the convolute neural network a shot. We use the word 2 vectors and the word embedded layers. We transferred each review into a fixed length of words, with each word represented by its word 2 vectors. The parameters we use are the following. The maximum number of words for each review is 50, and the max number of word features in the word 2 vector model is 5,000. The architecture of the model are the following. We first use the embedded layer and followed by a dropout layer, and then we use the convolution 1D layer, followed by a max pooling 1D layer, and then a full connected layer, and also another dropout layer, followed by ILU activations layer, and finally a softmax layer. So the accuracy we achieved using these algorithms, the both training and validation accuracy is about 67%, and notice that we only use half the data due to the resource constraints, and we can expect more accurate prediction given more tense and computing powers. And the given image shows the training phase. We use 2 approach, and we also provide the value of entropy loss here.
Now let's get into some interesting demos. Once you get into the web page, you can see all the restaurants we have been processed, and if you click on one of them, it's going to give you all the tokens in a form of a graph to let you understand all of the tokens and its positive and negative and polarity. Let's just say we want to see the text beer, and it's got a positive of 96 and bar positive of 72. And if you scroll down, you can get to see all the reviews for the specific restaurants. And if you click on one of the token, you get to see all the reviews have this specific token, and it's going to be highlighted as the polarity, green for good and red for bad. How about its menus? Well, we can see the menus are pretty good, although there are some reviews where menus not so good. Alright, let's see any other. Whoa, this is not a very good restaurant. Well, the food is not too shabby. It got a positive of 80. And here's a bad review of the food. What about the manager? Well, we see some bad reviews of it, so it's not very good. What about its drinks? Well, the drinks seems to be good. Alright, what else? This is just another restaurant where the service is pretty much 50-50. We can see some of the reviews gave pretty bad opinions on the service. About food, the food is not too bad. Most of the reviews seem to like the food. How about the orders? Well, there are some reviews saying that the order is not so good, but there also are some good ones. Well, to conclude, we basically did 3 things. The first one is we used visualization technique to explore the data, get the overview of the structure of the data, and we generate words cloud, identify important features. The second one is that we used machine learning algorithms to perform sentiment analysis and predict the review stars. Well, last but not least, we built web pages to let users to explore restaurant reviews interactively. Well, but that's not all we had in mind, because there are various interesting questions can be explored on the Yelp datasets. First of all, we are thinking about doing some graph mining to figure out who the trendsetters are, to figure out how much influence does people's social circle have on their business choice and their ratings. Well, the second one, we were thinking about what are those seasonal trends? Are there more reviews for sports bars on major game days? And if so, could you predict that? Well, the last one we're thinking about is to get the location mining and urban planning. How much of the business success is really just about its location? Do you see reviewers' behavior changes when they travel?